pick any positive value of n. I bet this expression is divisible by 7, no matter how big the value of n is. Let's see how these two terms team up and make an expression which is divisible by 7. So guys, welcome to the channel MyOneTeacher. In this video, we will prove this using principle of mathematical induction. Let's start. So the question is, prove that 11 raised to the power n plus 3 times 4 raised to the power n minus 1 is divisible by 7 for all positive integer n. So as I said, we will do this using principle of mathematical induction. So let's do one thing. Let's first check for n equals to 1. Now for n equals to 1, the given expression will be 11 raised to the power 1 plus 3 times 4 raised to the power 1 minus 1. So this will become 11 plus 3 times 4 raised to the power 0 is 1. So 11 plus 3, that is 14, which is divisible by 7. So we can say it is true for n equals to 1. Now next, the main part of the solution. We will take the statement is true for n equals to k. Then we will try to prove the statement is also true for n equals to k plus 1. If we can prove this, we can say the expression is divisible by 7. So let's do this main part. So now let us take the statement is true for n equals to k. So we can write it as 11 raised to the power k plus 3 times 4 raised to the power k minus 1. Now since the statement is true, we can write this one as 7m because it will be divisible by 7. Let this be equation 1. Now we have to check the statement is true for k plus 1 or not. We can use this statement since it is true. So for k plus 1, the statement will be 11 raised to the power k plus 1 plus 3 times 4 raised to the power k plus 1 minus 1. Okay, so if we can prove this expression in the form of 7 times something, maybe n, then we can easily say this is also divisible by 7. So now let us try to make it in this form. Obviously we can use this equation 1. So let us simplify it. This can be written as 11 raised to the power k times 11 according to exponent rule, plus this will become 3 times 4 raised to the power k. Now let us do one thing. Let us take 11 common because we'll try to bring this expression. Now if we take 11 common, we'll get 11 raised to the power k. That means we are getting the first term. Second term, but see, we cannot take 11 common from the second term, but we need this. So let us do one thing. Let us write this one, 3 times 4 raised to the power k minus 1. Now this is extra, so we have to eliminate this. So minus 3 times 11 will also get multiplied. 3 times 11 times 4 raised to the power k minus 1. And this 3 times 4 raised to the power k is as it is. Sorry, this will be plus 3 times 4 raised to the power k. Now this we can write as 7m from equation 1. So 11 times 7m minus 33 times 4 raised to the power k minus 1, that we can write as by 4 according to exponent rule, plus 3 times 4 raised to the power k. So this will become 11 times 7. So 11 times 7 is 77m minus, from this 2 we can take 4 raised to the power k common, minus 4 raised to the power k. So this will become 33 by 4 minus I2 common, so minus 3. Clear? Any doubt you can ask me in the comment box. So 77m minus 4 raised to the power k. If we do LCM here, 4 and 4 times 3 is 12. 13 minus 12 is 21. Okay, So now from here we can take 7 common. If we take 7 common, we'll get 11m minus 4 raised to the power k times 3 by 4. That means 7 times something. That is, this expression where we took n as k plus 1 is also true. That is divisible by 7. That means by the principle of mathematical induction, we can say the statement is true for all value of positive integer n. So that is our proof. So if you want me to solve more difficult question from this mathematical induction, so you can inform me in the comment box. We will meet in another video. Thanks for watching.